The moon is dumb. I hate doing the moon. Most people don't even ever learn how to do the moon. It's not fun and it's a pain in the ass. But we might as well go over it. Sorry to dissuade you. So for this problem, again, we're simplifying the amount of work we have to do so we don't have to run through everything every single time. We're going for the 25th of November. I've already set our GMT time, so no chronometer, whatever, is 15:30:08. And the moon has a height of, a sextant height of 21 degrees, 33 minutes, index error, height of eye, whatever. So we'll skip to the 25th of November. Here we go. You can see why people don't like the moon once it focuses. It's got so many different things going on. Now, GHA and declination, just like with everything else, it has a V value, and it's gonna work exactly like it does for planets. So don't let that freak you out. It's just the same process as with planets. Little d, also the same process as with planets. For both of them, remember, you always need to check whether it's increasing or decreasing. Here we finally have a good example. You can see over the course of the 24th of November, the little v value for GHA goes from 15.2, stays 15.2, drops to 15.1, increases to 15.2, drops again to 15.1, and then starts to drop, increase, drop, and so on. And it's GHA, well, the GHA does always increase, but you need to remember, actually, this is always positive, sorry. This is always positive, it just changes a lot. So you need to check it here. Instead of being written at the bottom of the page like the planets are, it changes by the hour, so it's got a specific value per hour. The declination, you can see here, the little d is a very large. It's 10.4. Normally, little d is like 0.9. And you can see it also changes hourly. You can also see here, sorry, this is what I meant. The declination could increase or decrease at any time, and it will fluctuate which way it goes. I can't seem to find an example of it happening here. However, trust me, it can drop down sometimes for whatever reason. So look to make sure that from 1 hour to the next, the number does increase or decrease, and use that. Finally, we have the HP value. While little v will go with GHA and little d will go with declination, your HP value actually goes to your altitude correction. So you're working with HS to HO when you deal with this. So for the purposes of our problem, we're not going to do this. We're not going to find LHA at all. But just remember, you treat it just like you would a planet. You apply the little v value, interpolate it by the minutes and seconds to add it to your GHA, while also doing your minutes and seconds to your GHA. You interpolate your little d value to add to your declination. Then for HP, that's the one that we're going to actually learn here. So we have the 25th of November, 15:30:08. So we're going to come down to here's the 25th. 1500 has an HP value of 54. So we're going to write here, HP is 54. It's technically in minutes. However, honestly, I don't know what HP stands for. And the theory, well, when you do the use it practically, what its unit doesn't even really matter. However, it is in minutes. So now we're going to set up HS to HO. But we're going to look at our table. This is way in the back of the book. So if you flip, here's our daily pages, minutes and seconds over here. Moonrise, stars. The last page of the book, way in back, is our altitude corrections for the moon. So we don't care about this one. You can see for the normal altitude correction, it doesn't even have it's so blurry. It doesn't even have a section for the moon. It's just sun, stars and planets, dip. And if you skip over here to the below 10 degrees one, it's still just stars and planets and the sun. Actually, it's just the sun. I guess they don't ever even want you to bother trying to... No, there's stars and planets there. Okay. Regardless, this is the altitude corrections you use for the moon. It's got its own dip table. I don't know how measuring the moon is going to impact your dip. I think this is just a repeat of the dip table in the front of the book, because this should theoretically be in no way connected to the body that you take the measurement from. How you use this? Firstly, any measurement below 35 degrees of height, you take this page. If it's from 35 to 90 degrees, so if the moon is higher in the sky, you use this page. That's the only difference between the two. You use the same process for both. How you use it, though, is explained right here. And what you do is you work with the first column first, similar to the height of tide at any time table, where you're working from one column down to from one table down to the next table. You take your apparent altitude and you locate it. So you can see here's all of the altitudes in their degree values. So 0 to 4, 10 to 14, 20 to 24, and then they're broken down more precisely. So here's everything for 15 degrees, here's everything for 17 degrees, here's everything for 19 degrees. And then here's the minute values of your apparent altitude. So if you're 17 degrees, 30 minutes, you intersect there and you get 60.2 minutes. You write that off to the side. You don't use it yet. You just write down 62.6 minutes. Then you follow this column down. You remain along this column until you get down here. Lower and upper here is the limb. So the moon, you can measure the lower limb and the upper limb, just like the sun. Importantly, the moon, actually, you will measure the upper limb more often than you do with the sun. Because for the sun, there's no reason to measure the upper limb. You can, but there's no point to doing so. Well, I guess if the sun was obscured by clouds, but only the bottom was obscured, then you could use the upper limb. Hasn't really ever happened to me before. If the sun was only partly obscured by clouds, I would just not take the shot because it's probably not reliable anyway, because you also probably can't see the horizon in that situation. But it's possible. For the moon, though, it's a lot more common because, the moon could be a crescent, and it could be a crescent that looks like this, in which case you can't see where the lower limb of the sun is, so you would have to take, or the lower limb of the moon is, so you would have to take the upper limb. So that, of the few times that I have measured the moon, which I've done mostly as like a flex before, I have taken the upper limb. So anyway, you find your first correction, you follow the column down until you get here, and then you pick whether your lower limb or upper limb. Whichever one it is, you follow that column down, and you follow it until you intersect with your HP value. So we had an HP value, I think, in this example of 59, which you would have to choose between 59. It would technically be closest to 60 here, and you would pick this correction. Now, as it explains, you then add that correction and this correction to your HA, and that will give you your HO. If you choose the upper limb of the sun, you would add that correction to HO and then subtract 30 minutes. You would only do that for the upper limb of the sun. So let's go back to our problem. And for this case, let's actually say we measured the upper limb of the sun. And you can see we're going to work HS to HO. So we're going to write it out differently this time. It'll be HS, IE, dipped. That's, of course, the same. That has nothing to do with the moon. We're going to get our HA. And then we're going to write C1, HP, C2, and And then we'll just do minus 30, question mark, and HO. So HS we said was 21 degrees, 33.0 minutes. Index error is 0.8 off. Height of I is 40 feet. Okay. First thing we do is we find what 40 feet is equivalent to. So you can come here, follow it down. Here's 38.9 and 40.1, so minus 6.1. I'm actually gonna check that with the normal dip table, because I'm curious. They should be exactly the same. So if I do 40 feet over here, it should also be minus 6.1. And it is. Okay, yeah. So this is just a copy. There's nothing different about this. It's just the normal dip table. So minus 6.1 minutes. Now, we apply these two corrections. So 0.8 minutes off for your index error. You actually add plus 0.8, get 33.8, minus 6.1, 27.7. Okay, so our HA is 21 degrees, 27.7 minutes. So we're going to come now to our full apparent altitude table. Pick our page. So we either have 0 to 35 or 35 to 90. We're going to go with 0 to 35, obviously. There's nothing different about these. It's just they couldn't fit them all on one page. We follow it down. We're looking for 21 degrees, 27.7. So here's the 20 to 24 column. Here's the 21 box. And 27.7 is closest to 30. So we're going to follow the 30 row. And we get 61.9. So for C1, for correction 1, we have 61.9 minutes. HP is 54 minutes. And like I said before, its unit doesn't really matter because all you're using it now for is, now that we have this picked out, we're going to follow our column down. We've gotten to lower and upper limb. For this problem, I said we're doing the upper limb. So we're going to follow the upper limb column now until we intersect 54, which you can see is right here. So our value is 1.2 minutes for C2. If our value was, if we were using the lower limb, it would be 0.6. And if our HP was some other value, we'd go further down. So we got 1.2 minutes. 1.2 minutes. Good. Now, do we add or subtract? Do we subtract 30? Yes. Because we're using the upper limb. So we know we have to subtract 30 minutes from it. So we're going to add all of this together except HP. Remember, HP is just for finding your row. It's not actually added to anything. So we're not going to add HP, but we're going to add C1 and C2 to HA, and then we're going to subtract 30 minutes. So we've got 27.7 plus 61.1 plus 1.2 minus 30. And amazingly, we got exactly 60 degrees. I don't know if that's a coincidence. I'm going to assume it is. Yeah, because I made up HS. So that has to be a pure coincidence. But it somehow came out to be exactly 60 degrees. So in other words, 21 degrees, 60 minutes, which carries over to being exactly 22 degrees, 0.0 minutes in the sky. That's our HO. I'm astonished that it happened to work out like that, but it did. So to review for this moon, if we go to the daily pages, you add minutes and seconds just like you do for the sun. You also add V, interpolated, just like you do for the planets. You interpolate D for declination, just like you do for the sun and the planets. Then you record the HP for the hour that you measured it at, and you bring the HP over so that when you do your altitude corrections, you first take your apparent altitude that you found, use it to find your correction number 1. Then you follow your column down, split between the upper and lower limb. You follow whichever column you need to, until you reach your HP value, and that will give you your correction number 2. You add your 1 and your 2 to your apparent altitude, and if you use the upper limb, you then subtract 30 minutes. If you didn't use the upper limb, then you don't do that. And then altogether, what all of that does in the end is gives you your HO, which somehow came out to be exactly 22 degrees for us.